Hi, and welcome to Lecture 3 in Introduction to Computer Science. Today we are going to take a deep dive into operating systems and what makes this computer do what it's supposed to do. An operating system is going to be the base software that runs on any computer. It's going to allow your user to interface with all of the computer components. With an operating system, users can manipulate, move, and store files. And finally, it's going to provide an environment where programs can execute. Let's take a quick look at some commonly known operating systems. Here is just a quick list of some of the more popular operating systems found on personal computers nowadays. Windows is an operating system provided by Microsoft, most commonly used with PCs. Unix is typically used with much larger computer systems, but it can be used for PCs as well. Unix is going to provide the basis for the next couple of operating systems that we have. A Mac OS runs on Apple machines, and a Solaris operating system runs on Sun Microsystem machines. Now it's owned by Oracle, so they're called Oracle machines. Finally, there is Linux, which is a non-commercial operating system, and it's built by computer hobbyists specifically for their interests. To normal everyday users, the differences in all of these operating systems is purely cosmetic, but they do offer different tools and philosophies for your more high-end users. Now let's take a quick look at some smartphone operating systems. Operating systems on smartphones, they're going to have the same purpose as an operating system on a PC. There's also a ton of choices out there for your smartphone, such as an Apple iOS or a Google Android. But what does an actual operating system do, and what is its function in life? All operating systems, regardless of the manufacturer or which operating system we're talking about, they're all going to have the same basic common functions. They are going to oversee the operation of the computer. They're going to store and retrieve files. They're going to provide some type of user interface so that the user can execute different various programs. And then finally, they are going to coordinate the execution of all of those programs running at one time. Let's take a quick look back at a little bit of history of operating systems and why we even have it. So within any operating system, each program running is called a job. So early computers could only execute a single job at one time. It would have to wait for that job to complete before moving on to the next. Each one of these jobs had significant setup time, a great number of loading instructions, and each job may have had its own unique setup. So this is where the birth of operating system really kind of came about. It came into play in order to reduce the time and effort required for setting up and executing all of these different types of jobs. Now, keep in mind, operating systems started to streamline this process of switching between jobs once they're completed. Now, first, jobs were just collected all at once without any interaction from a user. This is what we called batch processing. With batch processing, jobs are kept in mass storage and wait in what we call a job queue. The job queue basically organizes the jobs to be executed. Early job queues organize the jobs by first in, first out, or what we call FIFO. This means the jobs were run as they were loaded in the machine and into the queue in the same order. Now, batch processing had no monitoring from your user. It's just a set and go. But sometimes you will have an application that needs to have some kind of user input in order to complete the job. In this case, we call it interactive processing. With interactive processing, the user can then communicate with the job through a terminal of some sort. This allowed the user to interact with the program in real time as the program was executing. Now, up until now, each machine could only serve one user or one job at a time. This was called time sharing. You would have many users and only one machine to execute jobs. As computers have gotten faster and more advanced, they've now gotten to a point where you can start doing multitasking or multiple tasks at once. Multitasking, we're talking now about one user performing many different tasks at the same time. The next big evolution of the operating system was the development and the implementation of microprocessor machines, where you've got multiple processors running at one time. In order to be the most efficient that it could be, operating systems now needed to take into account how to explain to these processors and how to decide which processor is going to run what job. The operating system is then going to have to balance the load that is being done by the computer. Okay, so that's called load balancing. Lastly, operating systems have implemented embedded systems. This is more for unique Internet of Things type computers, but it's going to be a dedicated specific task already coded into a specific device, such as a home appliance or a cell phone even. These embedded systems can conserve battery, meet real-time deadlines, and they can even operate with no human oversight. The whole point of the embedded system is that it is only doing one task at a time, so it is always in the main memory of that machine. Now, let's look at some of the different software systems that an operating system will deal with. So, all computer software can be classified into two major broad categories. We have application software and we have system software. Application software is going to be what your user wants to do, typically word processing, databases, gaming, things like that. The system software, on the other hand, that's going to perform all of the tasks for the actual operation of the computer itself, such as displaying to a screen or taking input from a keyboard. This is the category that is the base structure of the operation of the entire computer. System software can then be divided into two additional categories. You have utility software and then operating system software. So let's take a closer look at each one of these two categories. Utility software is going to include anything that's not the operating system. So these are going to be utilities that you want your computer to perform, such as disk formatting and data compression and even network communications. But what's really interesting is the operating system components. So these components can be broken down into two different categories. Once again, we've got the user interface and the kernel. So the user interface is the portion of the operating system that is going to handle any kind of communication between the user and the kernel. The early user interfaces were text-based, such as a DOS interface, and they were called shells. And more recent ones do use a graphical user interface or a GUI. Just remember, this user interface, it's just a layer of the operating system, and it's just there to interface, just like in the graphic. Now the kernel itself is the heart of the operating system. The kernel is the software that does everything the computer needs to do. Some of these functions can include the file manager and device drivers, memory manager, the schedule and dispatcher. So let's take a closer look at a few of these kernel operations. Let's start with File Manager. So a File Manager is going to deal with your mass storage. We talked about mass storage a couple lectures ago. Most file managers are going to allow your user to organize your data by creating directories or folders. It depends on your operating system as to what it's called. But basically what it is it is an opportunity for your user to group like data together, however they want to. Now, users can create folders inside of folders inside of folders, and in order to be able to access this, you need to know where it is. This sequence of exact locations is called your directory path. That's really all there is for file management. Let's take a closer look real quick at memory management. The memory manager portion of the kernel, this is going to ensure that the main memory of the computer is being used in the best, most efficient way possible. Memory managers can actually create an illusion that your computer actually has more memory than it really does. It does this by creating something called a virtual memory. Virtual memory is going to be a reserved space on the computer in the mass storage that is going to be used as if it were main memory. Now, with virtual memory, your computer is going to switch back and forth between the main memory and the virtual memory, and the example they give in the book is it plays one of those shell games of shifting these blocks of data around. Now, these blocks of data we call pages, and it's just going to move the pages in between the main memory and the virtual memory. This is going to allow your computer to run much faster and more efficient without actually needing to install more memory. But how does this operating system get started? So it takes care of a lot of items within the computer, right? But it does have to get itself started somehow. The operating system is going to start through a process called bootstrapping, or booting for short. Each time the computer is turned on, the operating system is then booted, and what this does is it's going to transfer the operating system files from mass storage into main memory. In some cases, parts of the operating system can reside in that ROM or read-only memory instead of main memory. This group of instructions is called a bootloader, and it's considered a type of firmware. Now, firmware just means that it is instructions that is pre-imprinted into memory which can never be changed or altered. Either way, the CPU is going to run the operating system software as soon as the power is turned on, and this is how it starts on your computer. Now, another task of your operating system is that it does oversee the coordination of program execution, utility software, and other units within the operating system itself. In order to do this, let's start with a concept called a process. So a process is a fundamental building block of the modern operating systems. A process is an activity of executing a program under control of the operating system. The current status of this activity is called the process state. The process state is like a snapshot of what is happening in the machine at any given moment. Some information in this process state includes the location of the program being executed or the program counter, the values in the CPU registers, such as the general purpose register, and finally, any associated memory cells that are associated with what's in those registers. The scheduler and dispatcher in the operating system is what is going to coordinate all the processes that happen on your machine. The operating system keeps track of all of these processes by using something called a process table. The scheduler is going to add new processes to the process table and then also remove processes when they are complete. The dispatcher, on the other hand, that's going to determine how much time and the number of resources each of these processes is allowed to take up within that process table. Time is going to be divided into short segments called time slices, And process switches are then done across these time slices. When you're getting towards the end of your time slice, the process is then given something called an interrupt, and it's just like an interrupt is if you interrupt a conversation. At the interrupt, the current state of that process is then recorded so that it can be picked up right where it left off at a later time. This is how your operating system can do so many things at one time. So in order to wrap up today's lecture, let's take a quick look at operating systems and what their parts that they comply with in security. There are two different types of security that we're going to look at when dealing with the operating system. The operating system has a vital role in protection of the system or security. So now in this case, we're only looking at security that is related to operating systems. So we're going to look at attacks from outside and attacks from within. First, one task that the operating system performs when related to security is prevention of unauthorized access to a computer, especially if you have computers that are used by multiple users. This would be considered an attack from the outside. Now, operating systems use login procedures to determine what access that user has. There are such things as super users or administrators, and they're going to have full access to everything on the operating system. These types of users also have the ability to monitor activity happening within the computer system and who's accessed that computer. Now, some problems with attacks from the outside are if your user has an insecure password or if a sniffing software is installed on your machine. Now, sniffing software is going to record activities and send that to some outside source to be used in order to gain access they wouldn't otherwise have. You can keep an eye on these types of issues by using auditing software. Auditing software is going to run on your machine, it's going to monitor any activity and report back any suspicious activity to your administrators. Now let's take a quick look at attacks from within. Attacks from within happen when your user already has access to the computer. So either they have a stolen username and password, or you have a legitimate user that wants to use it for non-legitimate reasons. How can we protect information then? Well, one way is to limit the access to only what that user could possibly need. You can restrict areas of mass storage or memory based on that user's login information. Now, without restrictions, users could inadvertently erase operating system files or even do worse. So, being able to gain access to memory that you should not have access to, that's a problem. You can actually really do some harm to your computer. To protect against this, operating systems have what they call privilege levels, and this is going to indicate what the user can and cannot do within your system. Along with your privilege levels, you have privilege instructions, which are going to explain to your user what they can and cannot do. So those are some security prevention items that operating systems have already built into them. That's all there really is to operating systems. So regardless of what type of operating system, they all work in the same manner. They all have the same purpose in life. They're just going to present and show a little differently. As always, if you have any questions, comments, concerns, please email me and let me know.